Hi, everybody. Coming back at you again with part 2 of Sunday's investigations. It is now 1:10 p.m. Looking at the PowerPoint for Chapter 8, and we're going to do some graphical user interfaces. So those are the objectives for the section. Most modern computer systems employ a GUI, or graphical user interface. What this does is it displays texts as well as small images called icons that represent objects such as directories, files, command buttons, and drop-down menus. In addition to entering text at keyboard, which is what we've been doing on the command line, if you got a GUI that pops up, you can click on an icon, and click on a drop-down and select things. So what we've been doing so far is we've been having terminal-based user interface, and that's different from a GUI, a graphical user interface. So both types of programs perform the same type of function. However, their look or feel from a user's perspective are different. If everyone had to do everything on a command line, there would be far fewer people that were able to use computers. Like my mom couldn't use a computer if she had to do all the command line stuff that we've been doing throughout the semester. So a terminal-based user face has several effects on its users. They're constrained to reply to a definite sequence of prompts for inputs. Once an input is entered, there's no way to change it. To obtain results for a different set of input data, users must wait for command menu to be displayed again. And at that point, the same command and all the other inputs must be re-entered. So down here is an example of the tax program that we had way back in the day, where it prompts the user to enter the gross income, and then it prompts the user to enter the number of dependents, and then it tells you how much the income tax is. And if you want to do it again, you can just run it again and put in different numbers. So a GUI version of this might look like the following. A window might pop up with a field for you to enter your gross income, and a field for you to enter the number of dependents, and then maybe a box for you to click when you're done entering those things, and you can hit compute. And then you could code it to be able to compute again if you enter in different numbers, if you go back and forth. So behind this, there is the terminal-based program running, but you can do certain codes that would make this popping up look fancier for somebody using it. So a GUI-based version of this program has the following effects. The user is not constrained to enter inputs in a particular order. And running different data sets does not require re-entering all the data. So a GUI seems to be an improvement on the terminal-based user interface for the users. Event-driven programming. So user-generated events, like clicking, is an event that a user can do. They trigger operations and programs to respond by pulling in inputs, processing them, and then displaying results. So event-driven software and event-driven programming are two examples of that. The coding phase. So this is super complicated. This is the stuff that Fred was doing when he gave us his talk, and there's many things happening. The first one we do will be very simple. There won't be a lot of things happening, but it still looks kind of complex. So basically, we define a new class to represent the main window. We then instantiate the classes of window objects needed for the application. So we'll add things like labels and command buttons, and then we position them within the window by basically referring to where they go in like a grid type format. Kind of like with images, the top left will be 0, 0, and the bottom right will be width of window -1, comma height of window -1. Then we'll instantiate the data model and provide any default data in the window objects. Then we'll register controller methods with each window object in which a relevant event might occur. And then we'll have to define these controller methods. And then finally, you do a main loop that actually does the GUI. So there are many libraries and toolkits of GUI components available to the programmers. like Fred was saying in his talk to us, the Python community is a very sharing bunch. And the most popular one that he referenced was tkinter. And that has lots of different classes for Windows and different types of window objects. And then there's this Breezy Python GUI, which the author has developed for us, which is a wrapper around tkinter, which kind of insulates us from a lot of the scary that is in tkinter. All right, so here's an example of just a simple program that's going to pop open a box, just giving us a message. So not a lot happening here. I took this and put this into Anaconda. So let's run over there real quick. Where is my tkinter? Okay, so here is my Anaconda. So I've been doing a couple things here. First off, I opened up the Breezy Python module, which you can find on Canvas. So if we go to Canvas and we go down to images and Breezy Python GUI, you'll need to have this Breezy Python GUI in whatever directory that you're working in. So you should click on that, download that. I've got that in my Python directory that I'm working in on my computer. And I just opened it to flip through it. And as I suspected, it's pretty gross. Got a lot of things in here. So basically, it defines a class called EasyFrame, which is a version of the TK object frame. So we're going to create easy frames, which are frames which already have a lot of the work done to them. So all these methods there are there to make our lives easy. So this is defining a bunch of methods on the class EasyFrame. So anyway, here's label demo. I accidentally named it label demp. And this is the code that you saw on that last slide in the PowerPoint. So from Breezy Python GUI, import EasyFrame. And then we're going to define an instance of the EasyFrame class. So this is just going to be a window that we're defining. So class, label demo, EasyFrame. It looks kind of like when you define a function. And then we're going to set up the window by saying def underscore init underscore self. And then underneath that, EasyFrame dot underscore init underscore self. And then we want to add things to that EasyFrame object. So we'll say add label, and then the text will say hello world. And then where do we want that hello world to go? It'll start in the top left, row equals 0, column equals 0. And then we'll define a main function, which we'll always have when we do one of these GUI windows, which basically does the main loop that Fred was talking about. So you call label demo, the thing that you created, and you say dot main loop, open close. So that makes it pop up. So I'm just going to run this program. And you can see at the top left of my screen, this guy popped up, hello world. Now, much like before with the turtle, I've been noticing that even when I close this, I still have this kind of phantom Python down here. So I know it's a pain in the butt, but I'm going to get the pinwheel spinny thing. I'm going to go up here and I'm going to force quit my second Python window. I end up doing this a lot. You probably don't need to do this if you aren't using Anaconda, so we can have a more full discussion on whether or not we want to use Anaconda next time we do this. Okay, so back to the PPT. So that's the code for getting just a window to pop up that says something in it. So this is a template for pretty much any GUI program you're going to do. You're going to have that same from Breezy Python, import EasyFrame up here. Oop. And then you're going to have anything else that you might need to import. And then you're going to define a class, and you're going to call it whatever you want to call your window that's going to pop up. So we called our last one label demo. And then we're going to have the init method definition. So like we had before, define underscore init underscore self. It will always say that. And then it's always going to say EasyFrame dot init self.